Morning class, and this is your lesson on multiple objects 2. Today we are going to be able to draw free body diagrams for two hanging objects and use those free body diagrams to solve for acceleration and tension. So once again, this is kind of the same thing as yesterday. Free body diagrams, we're going to draw two of them, and then we're going to take those two free body diagrams, make up some equations, and then take those two equations to solve for what we need to solve for. So it's very similar, except now we have hanging objects instead of objects being pushed. But you will notice that the logic is going to be the same for all of them. The logic is going to be the same for all of them. So if you understand the logic behind it, then you should be able to get it. So right here, we're going to say this is a 1 kilogram object. We're going to say this is a 4 kilogram object, and we are going to say that this is being pulled by 30 newtons. And so we want to know the acceleration of these two boxes, and we also want to know the tension in the cord. We want to know the tension in this wire right here. We know it's 30 newtons up top. We want to know what it is in the middle. So we're going to draw, I'm going to do it first this way. I'm going to draw a free body diagram for each box here, and then I'm going to go through and do it for the whole system. So I'm going to do this problem twice again. So for the 1 kilogram box, on this 1 kilogram box, it has a force of 30 newtons pulling it up. It has a force of gravity pulling it down, and it also has tension pulling it down from the string, right here. So those are all three forces. Now let's do the other box. I'll do this one in blue. On the other box, we have the string pulling it up, and we have gravity pulling it down. So this is the 4 kilogram box. Okay, so we have two free body diagrams. Now we can set up two equations. So let's do this first one here. The 1 kilogram box. We're going to call up positive. We're going to call down negative. So in this situation, we have F net equals MA. F net is going to be equal to the 30 Newton force minus 1 kilogram times 9.8 meters per second squared. And I'm going to change that. I'm going to just go with 10 because 10 is going to make things a lot easier since we're just trying to get the concept right now. So we have 30 minus mg, and then it's going to be minus T1. Okay? So that is our first equation right there. This equals 1 kilogram times A. So our F net is going to be these forces here, 30 minus mg minus T1, and that equals MA, M being 1 kilogram because we're only looking at the 1 kilogram box. Now, the other one, 4 kilograms, T1 minus 4 kilograms times 10 meters per second squared equals MA 4 kilograms times A. So I'll write F net equals MA. So now we have two equations, two unknowns. So I'm going to rewrite these equations on top of each other, okay? And I'm going to simplify them a little bit. So we have 30 newtons here minus 10 newtons here minus T1 equals 1 kilogram times A. I'm going to rewrite the second equation under it. T1 minus 40 newtons equals 4 kilograms times A. And I'm going to pick a different color here. Now, if you remember from algebra, if we have two equations, two unknowns, we can combine those equations. So, if we added these two equations here, if we added these two equations up, we would get 30 newtons minus 10 newtons minus 40 newtons. And you will notice here that it is a minus T1 and this is a positive T1. So negative T1 plus T1, these cancel out. This equals 5 kilograms times A. So 30 minus 10 is minus 20. So 30 minus 10 is minus 20. 10 or minus 20 minus 40 is negative 20 newtons equals 5A. Therefore, A equals negative 4 meters per second squared. So, what does that mean? We are pulling up with 30 newtons, but acceleration is negative 4 meters per second squared. So, so the question we have is this box traveling up or down? And because I called this direction positive and our answer was negative, that means it is traveling downwards. And so we have this answer here, and we have these two equations here, both. All we have to do is plug A into one of these equations and get our other answer. So to find tension. So if I plug A into this equation here, we are going to get T1 minus 40 newtons equals 4 kilograms times negative 4 meters per second squared. So this is going to equal 16 newtons negative. We're going to add 40 to both sides, and that means T is going to be a positive 24 newtons. So going back again, we drew two free body diagrams. We made up equations for each one. We combined them using our systems of equations. Two equations, two unknowns, and then we found one answer. Which was A equals negative 4 meters per second squared, and then plugged that back in. So that is the first way to do this. Now let's go to the second way. Okay, same exact setup. Oops, wrong tool. 4 kilograms times, and 1 kilogram, and this is being pulled at 30 newtons upward. So let's look at this as a whole system. Basically what I'm saying is I'm going to combine these two boxes and pretend they're just one big box. So if that's just one big box, I have mg pulling it down and I have 30 newtons pulling it up. So our equation is going to be F net equals ma. F net is going to be 30 newtons minus mg equals ma. So 30 newtons minus 5. Remember, it's 5 because it's 1 plus 4. That's a total. 5 times 10 equals 5 kilograms times A. So 30 newtons minus 50 newtons equals 5A. A equals negative 20 newtons. A equals negative 4 meters per second squared. So notice it is the same answer as before, and we were able to find it because we treated this as a whole system. So we were able to find A doing this. However, we cannot find tension internally, because this is an internal system. If this whole thing is the whole system, this tension is an internal force, and so we can't do that. Not in the whole system. But all we have to do is go back to go back to breaking it up individually. So now I'm just going to look at the 4 kilogram box by itself. This is the 4 kilogram box by itself. So I draw a free body diagram. mg is pulling it down. Tension is pulling it up. F net equals ma. T1 minus mg equals ma. T1 minus 4 times 10 equals 4 times negative 4, which I get from right there. So T1 minus 40 newtons equals negative 16 newtons. T1 equals a positive 24 newtons. Same answer. So once again, I looked at it as a whole system first to find acceleration, because acceleration is going to be the same for the whole system. No one box is going to accelerate faster than the other because they're attached. And then I went and I broke it down here in this 4 kilogram box into making it a whole system, into making it an individual system, so I can solve for the internal force of tension from my whole system.